So that's the semi-minor axis. A, it's hard to tell if they're talking the distance from the center to the focus or it's to the opposite, all right? So that A is all the way out. That's, what do you reckon that name is? Semi-major axis. Why semi? Yeah, it's only half. It's from the center out. The whole major axis would be all the way across. Okay. So what's the major axis length? If A is half, then 2A is full. And if B represents the half minor, then the whole minor is 2B. All right? You follow? Okay, now this is pretty cool. An ellipse is really like a circle that's been stretched and squished. And what is a circle's equation? X squared plus y squared equals 1. Now just do put the x squared plus y squared for now, because in a form it is a circle. But an ellipse is slightly different in that it's going to be stretched. Now you'd think that should be like a 2x squared, and actually sometimes you'll see something like that. But the standard form is usually x squared over a squared and y squared over b squared, and then over here it equals 1. Now this all makes sense. This is part of this day here is partially why I had you guys focus on double intercept. I don't remember if you did remember double intercept form of the line a couple weeks ago? Okay, now that was the best preparation for today. Now this equation and that graph go totally together very logically. Think if x equals 0. Now, if x equals 0, then this guy is gone, yeah? And therefore, y squared over b equals 1 is left, which means y squared is b squared. Oh, shoot, that's squared, right? Y squared over b squared equals 1. Sorry about that, I just said that wrong. Y squared over b squared is 1, yeah? Y squared equals b squared, and therefore y is square root, baby. Plus or minus b. All right, now, okay, you're probably thinking, okay, what? Well, when x is 0, where am I in the graph? Right at the middle. When x is 0, then y is either b from the center, or negative b. Okay, so you would say this point is 0b. When x is 0, y could be b, or 0. X could be a negative b. You follow? Likewise, if I take my hand and say y is 0, okay, so if y is 0, then this guy's gone, then the new equation is x squared over a squared equals 1, which means x squared equals a squared, which means x is plus or minus a. Now that also makes sense, because when y equals 0, where am I in the graph? When y equals 0, I'm not going up, I'm not going down, I'm right at the axis, yeah? And if y is 0, x is a, isn't that if you start at 0 and go a out? This is the point a to the right and no up or down. Or a to the left, no up or down. It's really easy to graph an ellipse then, by knowing that, oh, the denominator tells me of x tells me how far I go right and left. And oh, the denominator of y tells me how far I go up down from the center. It goes really easy. I do require you, we will require you to also find the foci. Now that takes a little bit of memory of where the string was, okay? If you were to imagine, I should have talked about this here. So remember when his hands were here and I went all the way over to the side? In that case, the string was like this, and then back to this one. Remember that? Okay. So that said, what if I took this little piece of blue and moved it over there. Follow? And you're probably thinking, what? Okay. So this still represents how long the string is. Okay? And isn't the string length then just the distance all the way across the long way? It's not?
No.
Why not?
It's from one.
Now you're making me doubt math. Did I break math? So yeah, it is. It's the whole string. Yeah, it is. You're messing with me.
It's not the entire cross. It's from one dot.
It was from dot to edge back to dot. Yeah? So when the marker was all the way over here, it was dot to marker to dot. But because this is double, over itself twice over, if I were to take that chunk and move it over there, isn't the distance across this then just equal to the length of the string? It is, okay? So don't sweat too much. My point though is this, that if I want to find where is this focus, I can make a little bit of a, I'm going to do it down here. I can make a right triangle between the focus and this point here and say, I know this is B, and this is the distance I want. How far is it to the focus? And I'm going to call that C. And I know that's totally kooking you out to see the hypotenuse, or C in the leg place, but it is what it is. You with me? How long is this part? 5. Yes. How long is that part? Let me give you this. Isn't that part just, let me give you a couple pages here. Isn't that whole diagonal part the same as the actual string length? Are you with me? Okay, sorry, I'm losing it now. Okay, my point is this. This blue right now, I'm going to make it green actually. That green is the string length, yeah? Okay, and the string length is actually the same as the whole major axis. So this green string length is the same as this distance from there to there. Therefore, this green length is the same as A, this major axis, all right? So if you want the distance to the foci, then you can use this right triangle here to say how far apart by saying really c squared plus b squared equals a squared, which to me is a bunch of, that's not going to stick. C's, b's, a's, blah, blah, blah. Okay, c is the distance to the focus squared plus the semi-minor axis squared equals the semi-major axis squared. And if A's, B's, and C's, if that stuff sticks to you, great. It never stuck to me. Okay, it's all, to me, it's arbitrary. All right, so let me show you what a problem looks like, all right? Oh, yes, sorry. What does that say? If I had a quarter for every time a student has said that, I'd be a rich guy. Okay? It says, this is distance to focus, okay, is semi-minor squared, and it equals the semi-major squared. Cool? Pythagorean theorem with the little components to this ellipse. Now, take a look at this then. If I asked you to graph this one's already in standard form, which is awesome. the first thing you're going to do is locate the center. Now, just like circles, we'll start centered at the origin, but then we'll shift it around, and horizontal shift and vertical shift and all that stuff. But for now, for today especially, our center is going to be the origin. All right? Then, I would love it if you just mentally cover up X, find Y. Now, you're actually not going to do that very long. You're going to do this in like 3 seconds. But when I say cover up X, find Y, that means when X is 0, Y would have to be plus or minus 3. So when X is 0, Y is plus or minus 3. Graph those points. When X is 0, Y is 3, or Y is negative 3. You know what? In other words, the number under the Y, that tells you how far to go in Y, up and down. Then cover up the Y, find X. If Y is 0, then this guy wouldn't be there, and X would be plus or minus 5. If Y is 0, X is plus or minus 5. So that number under the X tells you how far to go side to side, and then we go get out the string if you want to. All right. It then says graph and find the foci. The foci are always on the major axis. Write yourself a note here, please. I know the first example they were on the x-axis, and in this example they're on the x-axis. They're not always on the x-axis. They're always on the long axis. So always on the major axis, not always horizontal. Okay? In this case, they'll be on the x-axis because the longer axis is horizontal. But it could be an ellipse that stretches this way, and we'll talk about that in a second. Are you with me? For now, I'm just going to say it's somewhere here. I don't know that. And I'm going to draw the triangle. To find the foci, just put a dot on the major axis and draw a right triangle. All right. Now, in terms of sides, I know obviously this is 3. This, I know I put it at 4, but this is actually, I don't know really where that focus is. I just kind of put it there. I don't know that that's where it's supposed to go. Are you with me? And I do know this. How long is this? It's the same as the A, or the long axis, and the long axis here is 5. That, if I were to take my string and go all the way over and around, that is exactly the same as the major axis, semi-major is 5. You with me? You then, so when I say put a dot in the major axis, draw a right triangle, show the minor and the hypotenuse, which equals the major. Find the foci distance. By Pythagorean theorem, what's that side along the x? 4. Now that's this. I think you can see it's a 3, 4, 5 triangle. But what if it was ugly, like 2, 5? What would you do? Use Pythagorean theorem, yeah? Are you with me? Pythagorean theorem, the right triangle. In this case, it's a 3, 4, 5. We gave you a soft, easy example, so C is 4. So when I say C is 4, that's not the locations of the foci. The foci are the coordinates. So what are the coordinates of the foci? Here's one. It's 4 away, which puts me at negative 4, 0. And the other one is 4 the other way. There's another one over here. That's at 4, 0. Right? You can see it's really just Pythagorean theorem with those two sides there. Alrighty. Sometimes it is not in standard form for you, so you have to do a little work. So I guess call that step 0, put in standard form. When I say put in standard form, would you write this over here? Please say x's and y's on one side, constants on the other. And then divide by the constant to make 1. Okay. Now, this is what I mean. Do you agree that the first part of that is already done? X and Y's are on one side, the constants on the other. You cool? Standard form is all dependent on there being a 1 here, so I could say, hey, if this is gone, the 9 multiplies over, it's just a 9 still, and all that stuff. So I need to make that 20 into a 1. How do I do it? Divide by 20. Obviously, I have to do that everywhere. So I get x squared over 4 plus y squared over 10 equals 1, right? Now we find the center, which is still at the origin. What do you reckon it would look like? What would the equation look like if it wasn't? How do you shift something? Add or subtract. So what would it look like? So instead of maybe x squared, it might be x plus 2 squared, in which case it would shift to the left, or x plus 2 squared and y plus 3 squared, in which case it would shift left 2 and down 3. So we'll come to that later, but for now the center is still the origin. Now we find the x, find the y. Again, think of it like covering. So when x is 0, the numbers here you can probably see ahead of time are not pretty, but it is what it is. So when x is 0, this guy goes away, and y is plus or minus root 10, which we know is about 3 and change. I'm just going to call it probably 3.1, 3.5. All right? Y equals 0. When y equals 0, this guy's gone, and then x is plus or minus 2. So if I locate those points on my graph, which is way too low, all right, I start at the center and go right 3 and a little more, and left 3 and a little more. And if I really wanted to mark this well, I would say that's root 10, and negative root 10. And up 2 and down 2. I sure am doing something wrong. Thank you. Just assuming horizontal. Okay, thank you. Happening here? All right. Thank you for letting me not go too far. So when x is 0, y is 3, and heck, this is off. Sorry. Dang it, this is not. Okay, so hopefully a little less than 3 and 2 and 2. So you would describe this as what in the world is going on? What the heck, Sims? What's going on, bro? Oh, dang it. That was just like the coordination. All right, not bad. This is, so you would say this is a major axis vertical. Now this then is going to make for a little different triangle here. Remember I told you the foci are always on the major axis. So am I going to put them around here or on the y-axis? Okay, so I'm just going to say around there. And I'm going to draw to the end of the minor and label the three pieces. No, in this case, isn't the major just means longest. And isn't the longest here, the longest is vertical now, yeah? Okay, so in terms of the three sides of this, do you know what this side is? What is it? 2. Do you know what this side is? No, that's what we need to find. The distance to that focus is what's to be determined. And how long is this? Root 10, yeah? Or 3-ish, all right? So to find C, we're going to say something like 2 squared plus C squared is root 10 squared by Pythagorean theorem. 4 plus C squared is 10. C squared then is 6. And so C is plus or minus root 6. Now that's the distance to the focus, the foci. And now we need to actually name the foci. So is that root 6 going to be the y or the x? The y. We're going to go from an x of 0 up root 6 and from an x of 0 down root 6. Those are the foci. And are you with me? Okay. That's your answer. We did everything they asked. Maybe. What the heck is going on with this? I need to teach GC this way. All right. So your goal is to graph, which we did, and find the foci, which we did. So we're good to go. Pretty cool? Okay. Shall we try one off the homework? Yeah. Oh, you don't have homework. There you go. I mean, you do have homework. You just don't have it on you. And this, folks, sorry. You're happy for the I know. Of course. So let's go to number 7 and 8. What's going here, people? Are you all bummed up? Are happy? Alrighty. Mr. Joe, you got something to do good?
Yeah, it's tonight.
Tonight, yay! How do you say it that way? Soccer's fun. Why do you guys do stuff you don't like to do? I got soccer tonight. Yeah, I've got cross country tonight. I've got band tonight. Would you give 7 and 8? Can I use your book a little? Thank you. Oh, okay. 7. 7 is graph. This. And 8 is standard form and graph and find foci. Yes. Yes. Brian, where'd you put that? Oh, you put it here. I just dumped it into. There you go. That's.
I'm so tired.
It doesn't have the replacement or extra problems, so just I'll leave those on their own and I'll get them. If you know what you're doing, this should be already done. See, just like that. Oh. Does it say foci for the first one or no? Does it say first one? I say find the foci. Add in find the foci. For both. Yay. Who said yay? Oh, extra practice, extra credit for you. Okay. So, just tell me, where do I go? Side to side? How much do I go? 4. And up and down, how far do I go? 3. Is graphing ellipses the easiest thing ever, or what? Okay. When I put the foci on an axis, do I put them on the x-axis always, or the y-axis always? No. In this case, where do I put them and why? X-axis because it's the major, the longest one. When I say just put it down, don't worry about it being accurate, just put it somewhere and connect it to the origin, or not the origin, excuse me, the top of the minor, and label your sides. You know, this is 3. What else do you know? The hypotenuse is 4, and this is C. Pythagorean theorem, find C. It's not, come on now. 3, 4, 5, doesn't the 5 kind of have to be the hypotenuse? Yes, it does.
So isn't C supposed to be hypotenuse?
No, you're thinking Pythagorean theorem.
Yeah.
But this isn't the Pythagorean. Am I confusing you now? Just say C is the distance to the focus.
So C always is like those two sides to the square root equal that.
Yes, the triangle is always the focus side and the semi-minor and semi-major. All right? So what is C? Is it 5? Somebody was throwing that out there just to test us, and we're with you. It's root 7, yeah?
No.
So what is that's what? How about Pythagorean theorem? 3 squared plus C squared is 4 squared.
So it is. It's not. Yeah.
Well said, well said. No, C has to be the hypotenuse, and the hypotenuse is 4. No, say that again. 4 has to be the hypotenuse. 4 has to be the side by itself. You with me? All right, so what are the coordinates? Root 7, 0, and negative root 7, 0. Boom. Now do the other one. Put it in standard form first. What do you divide by? 36. You make the 1. X's and Y's on one side, constants on the other, and make the 1. X squared over? 4. Y squared over? 9 equals 1. How far do I go right, left? 2. How far do I go up, down? 3. Is this a major axis vertical or a major axis horizontal? Vertical. So when I go to put the foci, should they be on the x-axis or the y-axis? Y-axis, because it's the longer one. Always put them on the longer one. Connect to the end of the shorter one. Label the sides. You know, 2 is the short side. You know the hypotenuse is 3. And the missing side, you want to call it something else? Like M? What do you want to call it, Gigi? X? That feels wrong because it's vertical.
C.
How about F for foci distance? Right? Call it the distance to the foci. So 2 squared plus foci distance squared equals 3 squared. Foci distance is plus or minus root 5. Therefore, the foci are at the coordinates of 0, root 5, and 0, negative root 5. Wasn't that easy?
Yes.
Yay! Ellipses. Okay. Next time you get another one? Yes, you did so. Just walking around and in stuff? Okay.
I think those are the